Okay, so in this deferred math preparation, we will look at start from here, and the question says solve the radical equation. So radical equations are these equations of the form where you have a root somewhere. Yeah, you have a square root somewhere. Like as you can see in that question, we have that square root and the other one. So now to solve this, so we have 3 plus root of x plus 6 is equal to root over 11 minus x. So we have this. So in order to solve this radical equation, what you must do is you must square both sides. First of all, square this side, and that side you raise it to the power 2. So what this means is that we will expand this and you just get 9. 9 plus 6 root of x plus 6. Then this will be when this root multiplies with itself, that goes and you just have plus x plus 6. On the other side, you have 11 minus x. So now, at this stage, you can group the like term. So I will move everything that does not have a radical to the right sides, such that I remain with 6 root of x plus 6 like this equal to, so I'll have this 9 and this 6. When I add the 2, I get 15. So when I take it to the side, I get negative 15. Then I have plus 11, then negative x, then minus x, like that. Then I have 6 root of x plus 6, and this will be equal to, when I add this here, I just get negative, I get negative, this is negative 4, right? Okay, yeah, so I get negative 4 there, then minus 2x, like this. So this is what I get. And from here now, you can square again. So you square this side and you square this side. So when you square this side, you just have 36 multiplying by x plus 6. And then on the other side, you're going to have 4 by 4, that just gives you 16. Negative 4 by 4 gives you 16. Yeah. Then you have this by that, that gives you negative 8. Then you add the negative 8. It's going to be positive 8, I mean. That'll be plus 16. Plus 16x. Then you have plus 4x, like this. So now, at this stage, you can now group the like terms. You can group the like terms. So you have that. You have 36. 36 can multiply it by 36 multiplied by x there, then 36 multiplied by 6. What do we get? We have 36 multiplied by 6 gives us 216. And there you have 16 plus 16x plus that is 4x squared. Here we left out a squared. Yeah. So that's what you get. So when you do that, from there, you proceed and group the like terms. So let's say we move everything to the right. This will be 0 here. Then we have negative 16 plus 16 here. And you have negative 36 plus 16 here. And plus 4x squared. This will give us 0 is equal to, this will be negative 200. Then you have negative 20x plus 4x squared. Then, of course, this can be rewritten as 4x squared minus 20x minus 200 is equal to what? To 0. Then, from here, you're going to work out this quadratic equation. And in whatever way you're going to use, whatever method you're going to use, uh, Yeah, just make sure you work out this. So you have 4 there. So you can factor out the 4, and you have x squared minus, that would be minus 5x. Then you have 200 divided by 4 gives you 50. You have negative 50 there, and this is equal to 0. This is going to be 4. Then you have x minus half of this 2, half of 5, that's 5 over 2 squared, minus you square the half of 5. So that just gives you 25 over 4 minus 50, like this, equal to 0. Then from there, we are going to get that this is just going to be equal to, so you have, that would be 4. Expand out the 4, you have 4 minus 5 over 2 squared. Then that is just going to be negative 2 to 225. Okay, when you multiply by 4 there, okay, let me just multiply 50 by what? You get 200. So you have 25 minus 200 like this equal to 0. And that is just, yes, a negative 5 over 2. This is negative 225 like this equal to 0. Then 4 is going to be equal to x minus 5 over 2 squared equal to 225. Then divided by 4, you have x plus 5 over 2 squared equal to, you have 225 divided by 4. That gives you, so you just write it as a fraction like this, 2 over 4. Then you can now introduce the square root both sides. Okay, so introducing the square root, here we are going to get that that side we have x plus 5 over 2 squared is equal to, then here we introduce the square root as well, 225 over 4, and of course it's plus minus. Then this goes, that goes, and you just remain with x plus 5 over 2, x plus 5 over 2, okay. And then this is just going to be equal to plus minus. So this here is supposed to be a negative, right? I think we on this here and there. Yeah, we had said x minus, right? Is it? Or it's me who's recording the wrong things here? Hello, guys, are we together? Okay, are we together? All right. I don't know. Nobody's responding. But yeah, we had factored out, we had 4, then factored out x squared, then there we had negative 2, we had negative 5x, then we had negative 50. Yeah, so half of this is negative 5 over 2x, and squaring that, yes, we're getting 25 over 4, then minus 50. Of course, negative there, and then we got that. Yeah, so this is just going to be 5 over 15, I mean, over 2. Then we can work this to be, it's just going to be x is equal to 5 over 2, then plus minus 15 over 2, and this is just going to give you x as 20 over 2 and x as negative 10 over 2. X value is going to be equal to 10, and the other x value is going to be equal to negative 5. So when you have these radicals, you must test which value is going to be what. You must test the values that you get. because other values will not be valid when you plug them in. So let's test the values. So we have 3 here plus, we start with 10. So that will be 10 plus 6, and this is going to be 11 minus our 10 there. So here we will have 3 plus, this will be root 16 is equal to, I have my 10 minus 11 gives me 1. That will be 3 plus 4, and that is going to give me 1, and that gives me 7 is equal to 11. So we see that 7 is not, of course, equal to what? To 1. So, which means that x equal to 10, this will not be what? It will not be part of the solutions. X cannot equal to what? To 10. Then we check the other one. The other one, which we're going to now check, is the negative 5. So replace 3 plus root. You have negative 5 plus 6, and you have this is equal to 11. So minus minus gives us plus. So we get plus 5 there. And you have 3 plus root of 1 equal to, this here will be root of 16. And you have 3 plus 1. And there you have what? 4. 3 plus 1 is just 4. And 4 is equal to 4. Meaning the value of x here is just x equal to negative 5. So that's how you solve this uh, radical equation. All right, let's move on to the next question. So the next question says, solve the modulus inequality. And we've been given that the modulus inequality is modulus of 16 minus x squared, like that, greater than 2x plus 8. So this is what we have. So by definition of modulus, you can redefine the modulus as root over 16 minus x squared like this. Then this is greater than 2x plus 8. Then you're going to square this side and square the other side in order to get rid of that radical there. Then you just remain with the 16 minus x squared. Okay, there's a squared here. Then this has to be greater than 2x plus 8. Then you have squared. So now what you do next, you're going to expand this. So when you expand this side, you get 256 minus 32 x squared plus x to the power 4. Then cos, this is just going to be greater than, expand this other side, you get 4x squared plus 32x plus 64. So this is what you get when you expand. Now you can group the terms there. So we're going to have, if I bring this is just going to give me x to the power 4, then negative 32 x squared. Then I can bring this to the other side and I get negative 4 x squared. Then minus 32x. Then I have plus 256 minus 64, and this has to be greater than what? Than 0. Then when I simplify this, I get x to the power 4 minus 3 x squared. Then I have minus 32 x like this, and plus 92 is greater than 0. So here, when we add these two here, we get 36, and when we subtract this there, we get this 90. Oh, so when you add this, when you subtract this at first, we get the negative 36. Then you subtract these two, we get this 192 here. So we have this now. From this stage, what you have to do is you have to factor out. So solve this inequality, you have to factor out this side. But then, how do we factor out? We have that polynomial raised to the power 4, and it's going to be very hard to work with if we do not uh, factor this out carefully. So we can factor out using the fact using synthetic division. But first of all, we need to find what? We need to find one factor which makes this polynomial here equal to what? To 0. So then, if you were to get, if you say you test, so the way you get your factors, you're saying if we let this here to be our A and we let that there to be our B, then we say you have to get plus minus all the factors of this one here divided by the factors of that one there plus minus. So that's how you'd get that. So let's say when we do that, we get one of the factors, and one of the factors is just maybe it's what? 4. It's negative 4. So negative 4. And when we replace in this equation negative 4, we have negative 4 to the power 4 minus 36, negative 4 squared, negative 32. Then we have negative 4 plus 192, like that. And when we plug in this here, we just get so 4 to the power 4 is just 2. So this is 256. Then I have this here. When I do that, I get 576. Then that other one get 126. Then I get 192 there. So I can add these 3. So when I add that, I get 196, 192. When I add all that, okay. Okay, just a moment. I need to check this properly. So we had 256. Then when we multiply 4 squared is just 16. 16 by 32. I mean 16 by 36. Okay. Then here when we multiply 32 by 4, we get 128. Okay, this is supposed to be 128, not 126. That's when 128, then 128 plus 192 plus 256. Okay, that gives us, so I get 576, then plus 576. And this here just gives me 0. So meaning 4 is a factor of this polynomial. So I can use that to divide using synthetic division. So I'll say I have my negative 4, because it's x equal to negative 4, like this, yeah, which is a factor. Then I'll get the coefficients of these terms. So now, including the one which is not there, which is 0x to the power at 3. So I have to get that, because from here I'm reducing it to the x to the power at 3. So for x, this one is 1. Then for what, it will be 0. Then this which follows is negative 36. Then the one that follows for x is negative 32. And then it goes, that coefficient, that constant there is 92. So here I drop this 1 multiplied by the negative 4. I get negative 4 here. Negative 4 plus 0, I just get negative, excuse me, negative 4. The negative 4 by negative 4, I get 16. 16 plus negative 36, that gives me negative 20. Negative 20 by 4, that's going to give me positive 80. 80 minus 32, this just gives me 48. 48 multiplied by negative 4, I'll get negative 192. So this then gives me 0. The last part here is always what? This is the remainder. So one thing we must keep is we found one of our factors to be x to be equal to what? To 4. Then Continue now, meaning this equation is going to appear as x cubed minus 4 squared minus 20x plus 48. So we must factor out again this polynomial. So where is this part? So to factor out, we do the same. Find a number which makes this 0. So that is going to be when we replace here, we replace 2 where x is. So I have 2 cubed minus 4. Then I have 2 squared minus 20 multiplied by 2 plus 48. And this here is going to give me 8. This is 4 by what gives me 8. Then I have this will be negative 40. Then I have 40 what? 48. So when I add these two, I get negative. Okay, did I do that right? So here 4 by 4, this gives me 16. Yeah, this gives me 16. So when I add these two here, I get negative 56. Add the other two, I get positive 56. And this gives me what? 0. So meaning 2 is a what? Is a factor. So we keep the other factor here, x equal to what? To 2. Then we use synthetic division to simplify that polynomial further on down. And that's just going to be, so we have 2 here. Then get the coefficients. You have 1, negative 4, negative 20, and then 48. And this is going to give you, drop this 1 multiplied by 2, gets 2. 2 minus 4, you get minus 2, minus 2 by 2, you get negative 4, negative 4. Here we can add, we get 24, 24 multiplied by 2, that would be negative 48. And this gives you 0, and of course that's the remainder. And this is simplified to x squared minus 2x minus 24. And here we can just say this should be equal to 0. And then we can now factor out here. We can use any method. I'll use completion of square. So this gives me x minus half of this coefficient here is just 1. I square that. Then I'll have minus 1, because 1 squared is just 1, minus 25 equal to 0. Then I get x minus 1 squared. This, okay, this is 24. You add the 2, you get what? Negative 25. So this will be negative 25 equal to 0. Then you have x minus 1 squared is equal to 25. You introduce the square root there, plus minus here, and this just gives you x minus 1 equal to plus minus 5. X is going to be equal to 1 plus minus 5, meaning your x values is just going to be x equal to 6 and x equal to negative 4. So these are your x values. So these are what factors. Here we can include them to say we have x equal to 6, and then the other one is just x equal to negative what? 4. So the polynomial which we had was to the degree, the power 4. So meaning we factored it out to those factors, but then we still have to solve have to solve this inequality, and this has just factored out. So if I write these as linear factors, I'll have first one to be x plus 4, then I have x minus 2, then I have x plus 4, and then have x minus 6, and we're saying this should be greater than what? Than 0. So this is what it comes out to. But then these points that I found, x equal to negative 4, x equal to 6, x equal to 2, x equal to negative what? Those are my critical points, because this, of course, we're dealing with what? With an inequality. Those are my critical points, and I can use those critical points in order to what? To solve this equation. So what do? I can just say, okay, this. So Okay, I'll draw a table. So I'll start from here. Uh, okay, so here we will have, we can plug in the first one, which will have x plus 4. Then the other one we have is x minus 2. Then we have x plus 4. Then we have x minus 6, like this. Then, of course, the last one is this entire thing here. I have limited space here, but I'll try squeeze it in. I have x plus 4, then x minus 2, then it's multiplying again, x plus 4, then x minus 6. So I have those points here. Then my critical values. So my critical values, the lowest one I have is what is negative 4. So negative 4 is here. Then I'll plug in the other one is, so negative 4 is repeating, so it's okay just to have 1 there. And we have the other one, which is 2. Then we have here the other one, which is what? Which is 6. So those are my critical points. So now what do I do? So what these critical points represent, this is from negative infinity, meaning x is here up to negative 4. Then there from negative 4, x to 2, from 2 like that, x to 6. And of course, this other part is anything which is x greater than what? Greater than 6. Or you can write it as 6 like this to infinity. So yeah, so like this or that way. Now, what you do, you start picking out here. You pick out the value. You pick out any value. So here you pick out any value less than what? Less than negative 4. You pick out any value less than negative 4 and you plug in and see what we're looking for is the sign. So you check here when you plug in into negative 4, you plug in any number lower than negative 4 into here. Let's say we plug in negative 5. This here will give us a negative. Then into 2 here, plug in a negative, we get a negative. There it's the same, so we get a negative. And even this one here, when we plug in what's this, we just get a negative. So when you multiply this, so negative by negative gives you positive. Positive by negative gives you negative. Negative by the negative there gives you positive. So this your final what is just going to be positive here. We check for the other one when we plug in. So when we plug in anything in between here, let's say we plug in 0. So when we plug in 0, we will have a positive there. There we have a negative. There we have a positive, and there we have a negative. So negative, positive by negative gives you negative. Negative by positive gives you negative. Negative by negative gives you positive. So meaning here, our final answer is just going to be positive. Then we pick a value again in between here. So when we pick a value in between there, what we get is when we plug into there, we get to be positive. Plug there, we'll get positive. Plug into this one, we also get positive there. Then when we plug into this one with an x minus what, we just get that to be negative. And I'll have that this just gives me negative. Then I do the same now going on there. I'll get positive here. Okay, all these here just going to be giving me positive, positive, and that there will give me the last point to be positive. So now that I've had these, what I check for is my sign is what is greater than 0. So I'll check which regions are positive. And those regions are this one here. You have that one and that one. there. So these regions that are positive are the ones that will be what? Will be my part of the solution set. So it means the solution set, I'll write it in yellow. So the solution set, which is just your answer for these values. So we see from negative infinity and up to what here? Up to 2. So negative infinity. Then we're saying we're going up to 2. We close, then union. And we have from here that is going to go from 6. If you can see here, 6 towards to infinity. So we have 6 to infinity. And these here are going to be my solution for this question. Yeah, so I don't know if there are any questions here. All right, we can move on then. So we have this question. It says uh, solve this absolute value equation. So in the previous one, when we are solving for the modulus inequality, I showed you how to redefine that. You can redefine this modulus like this, plus what, 4, like this. Then, because you need to get rid of this square, you'd square, and then you have 2 minus x, meaning even this side you have to square. So you have something like this. But now, for this question, we use a different approach. We'll solve this equation by what? By graphing. We use graphical method to solve this equation. So to solve this equation using graphical method, you must first you graph this part and then the other part. So to graph that, so you have that here. So 3 in the modulus you have 3x plus 4. We say our y is equal to this, and we let our y be equal to 0, and we solve for x. We have 3x is equal to negative 4, then over 3, and x will just be equal to negative 4 over 3, which is like negative 1.33 something. Yeah, so it will be somewhere this side. Then this is your x value. Then you're saying if your x was 0, meaning your y is going to be what? To be 4. Your y is going to be what? To be 4, meaning your y-intercept is going to be 4 in that case. Now, this graph is the modulus. So if it was not in the modulus, it was not in the modulus, would have graphed this to be just like this at this point and there, where this point here is negative 3 over 2, and that point there is 4. Now that it's in the modulus, meaning the modulus always gives us positive values, meaning this side which is in the negative region will be reflected to the positive region. So you have that. This is just going to be, okay, so pass from here to there and this way to that way. So this is how this modulus what is going to look. So that will be negative 3 over 4 over 2, 4 over 3, then there to be 4. Then you have to graph this other function here, which is 2 minus x. So let's say y is equal to that. So when y is 0, we get that our x is just equal to 2. And when x is 0, our y is equal to what? To 2. So meaning that's where this linear graph is going to what? To cut. So when y is what? Is 2. So here and there. So say this point here is what? Is 2, where it's cut. That's the point 2. Okay, and you have the other part which is there, which is also 2. Okay, so you have something like this. So now, when you get something like this, what then are we going to do? So they are crossing. See where they are crossing? It is crossing at this point here somewhere, and this lies in the negative what? Negative region. So what are we going to do? So in order to solve this equation, so when you have it like this, it's in the modulus, this negative side, the negative side of the graph is going to be this line here, this line. this one going this way, this direction, is going to be defined by the negative of whatever you have what inside there. So it's going to be negative 3x plus, minus here, negative 3x minus 4. So this is what is, this side is negative 3x minus 4. Then this positive side here is going to be the positive variant, which is just going to be 3x plus 4. So you see that this line, this linear line is crossing with a positive part here. So what you do is you're going to equate that positive part, 3x plus 4, to the linear what equation which you had, which is 2 minus x. Then you solve for x. So this is going to give you that 3x, should be 3x plus 4 is equal to, that will be 2 minus 4. Okay, this is x. Then you have this will be 4x is equal to negative 2. Divide by 4, and there divide by 4, and you just get x is equal to negative 1 over 2. So this point meaning is what is negative 1 over 2, and that is your value of what? Of x. So that's how you find the solution for this absolute equation. All right. Next, we have this equation. So they're saying solve this rational inequality. So it's another inequality. So how do we do this? So we bring this part here to the left side. So that's going to be like this. That there will give you minus 1 over x plus, that to be x plus 3. And we're saying this should be less than 0. So here, you're just going to get, you can make this into a single fraction. You have x squared minus 4, then you have x plus 3. Then on top there, you're just going to have, that will be x multiplied by x plus 3, and then you have negative 1 multiplied by x squared minus 4, like this, and less than 0. That there is just going to be expand out, you have x squared plus 3x minus x squared plus 4. And this here just gives over. Here we can complete the square on this difference of two squares. There you just have x plus 4, 2, x plus 2, and then you have x minus 2. Then you have that other factor, which is x plus 3. On top, you just remain with 3x, this and this, subtract 3x plus 4, like that, and then down over x plus 2, then x minus 2, and then x plus 3. Then what you do, saying less than 0, less than 0. This here, you then get now your critical points by equating each of these linear factors to 0, including the one in the numerator. So when I equate those to 0, I'll get x is equal to, so I have x equal to negative 3. I have x equal to, negative 2, and I have x equal to negative 4 over 3, and then x equal to 2. So these will be my critical points, my critical values. So then I can come up with a critical table here, which will help me attain my solutions. So my critical table is going to be, so I'll have, okay, so I'll have it like this. Then we're saying, okay, there and there. So here we have our first what, which is negative 3. Then here I can decide, I can be plugging in my factors, which I had in the numerator. I had 3x plus 4. Then I have x plus 2. Then I have x minus 2, like this. And then I have x plus 3. Then, of course, that thing that I factored out, which was x, 3x plus 4 divided by those linear factors, which is x plus 2, x minus 2, and then x plus 3, like this. So these here are going to be my factors. Then continue to my critical points. The other critical point was -2. The other one was -4/3. Then I had the other one to be 2. Then this means values from here, I'll be obtaining values from -infinity to x to -3, -3, there x to -2, -2, like that, x to -4/3, and I have -4/3, like that, x to 2, then I have 2 less than x less than infinity. So I have these here. Then I can now be plugging in. So when I pick a value that is valid less than, that is less than -3, I will just get a negative here, a negative value. I put that there to be a negative. Here also negative, there negative. So when I multiply out these, I just get a positive value. I do the same with the others. I'll get negative there. I'll get a negative there. I'll get a negative and a positive. And this just gives me a negative. I do the same there. Pick a value in between there. I'll get a negative there. I get a positive. Then there I'll be getting a negative. Then I'll be getting a positive. Then a positive. So you can test that. Pick just any value. You'll be getting those there. Pick any value here. You get positive. Here you get positive, you get negative, then you get positive, then multiply this throughout, you just get positive. And there it gives you this, the rest give you positive throughout, like that. So then we are saying that we're looking for something that is less. This here was equated to what? Less. So it was we're saying 3x plus 4 over x minus 2, x plus 2, then I have x plus 3, and we're saying this is less than 0. So you look at where you're getting values. Oh, here it has to give you a negative. So you look at values where you're getting what? Negative. In what regions are you getting what values less than 0? Values less than 0 are negative, so you check it's this region and that region. So that's where what your solutions are, and your solutions will just be, so you have that one negative, 3 less than x, then less than -2, like this. You have this, and this is uh, union with what? With the other one, which is -4/3 less than x less than what? 2. So I can write this in interval notation as okay, let me just erase this part. So we'll get that is just going to be equal to, meaning a solution set is just going to be equal to -3, -2 union -4/3, then 2, like this. So this is the answer for this inequality. Next, we have this question here, and it says sketch the graph y is equal to 4 minus 4 minus modulus of 2x plus 6. So in order to sketch this graph, first of all, we can write this as y to be equal to negative modulus 2x plus 6, then plus 4 there. So when you have it in a modulus like this, it means everything that is what? That is negative is reflected upward, so you expect something like this. Now, this is multiplying with a negative in front, so it will be inverted and it will look something like this. Then what you have as well is you must check your vertical shift. So our vertical shift in this case is this value here of y. So we just say y is equal to what? To that there. So y equal to 4 there, that is going to be your vertical shift. So meaning this graph has been shifted in the what? In the y-axis 4 units up. So that's what you do in order to sketch this. So you plug in there, you draw x or y plane, you have your y, and you have your x here. So equate what is inside to 0. You have 2x plus 6 equal to 0, and you just have 2x equal to -2, -3, -6, I mean, divided by 2, you get x is equal to -3. So at x equal to -3, say x is equal to -3 here, then we are saying this has been what? Shifted 4 units up. Let's say 4 is what is there. So meaning at this corresponding point, like that, then you have a negative in front of it, so it will be inverted down. So it will open like this, then to go like that, then it continues to go. So this is how the graph will look. So if you want, you can get more points like these points here and that other point. And of course, that can be done by saying, so the way you can find those points, you're just going to say you have this. So we're having this equation where we have 4, 4, we have 2, I mean 2x plus 6 like this, and this here, we when y is what is 0, when y is 0, then you solve for this. So when you're going to solve for this here, you just have this means that you square both sides like this, and square there, and expand this throughout, you get 4x squared plus 24x, then plus 36 is equal to 16. Group that, you get 4x squared plus 24 plus 20 is equal to 0. And you get x squared plus 6x, x squared plus 6x plus 5, and this will be equal to what? To 0. So when you factor out this equation, you're going to just get that your x value, you have x equal to -5, and you have x equal to -1. So meaning these points where this graph is passing, you have x -5 there and -1 there. Then your y, the way you find your y is in this same equation here, in this same equation here, here where there's 0, you replace, where there's x there, you replace 0. So you have y is going to be equal to 4 minus modulus of, so that will be 0 plus 6. Then you have 4 minus 6, and this gives you -2. So, which means here where it's cutting the y-axis, it's just -2. And this is how you sketch that graph y is equal to 4 minus modulus of 2x plus 6 like this. All right, we do the last question. And the last question is on rational functions. So you have to sketch that graph. So how do we sketch that graph? So you have f of x is equal to 20 over, so I can write this starting with the negative here, squared, minus 3x plus 10. So in order to graph a rational function, what you must have is you must have your asymptotes. That's your horizontal asymptote and your vertical asymptote. So your horizontal asymptote is cutting the y, so it's the y value, and then your vertical is what is the x value. So now to find the horizontal asymptote, whenever this equation is bottom heavy like this one, where you have x variables down but you have nothing here on top, your y asymptote is always going to be y equal to 0. Then to find your x asymptote, you must solve this equation. So To solve this, you must factor it out, first of all. So solve what's on the bottom. 3x plus 10, and this saying should be equal to 0. Then factor out a negative there, plus 3x and minus 10 is equal to what? To 0. Then when you work out this equation here, you complete the square or you use any other method, you just get that your linear or your x values are going to be equal to x is equal to 2 and x equal to -5. So these here are the values that can make this bottom here to be what? To be equal to 0. And if the bottom, the denominator there is equal to 0, we will get something that is undefined. So we do not want it to be equal to 0. Thus, our vertical asymptotes are going to be those points. We are saying x equal to 2 and x equal to -5. So meaning here we cannot pick these points because they are going to give us 0 in the denominator, meaning they are not part of our domain. So those there. And then what do we do now? We have those points. Other points we can check for are what is the y asymptote. So y asymptote is when x is 0, replace 0 there, replace 0, you just get 20 over what? Over 10, and y is going to be equal to 2. So your y asymptote is y equal to 2. Okay, then from there, you can now sketch this graph. So you have draw your x or y plane, there, x, y, then you have a point at x equal to -5. So this point here, x equal to -5, won't have any valid points there. And you have another one, x equal to 2. So these are your two asymptotes that you have. Then you can check that as you plug in values that are greater than what? That are less than 0, you always that are less than 5, you always get negative values. And when you continue plugging into this this function here, you get that your corresponding values that you're going to be getting are going to be what? Negative. And you can pick values, but then this graph will come like this. Okay. And this other side as well, you'll be getting the what? The same to be like that. Okay. Then we have our point where we have y is equal to what? Y is equal to 2. That's our intercept, y equal to 2, meaning, and as we can see here, this is a what? Quadratic equation. So we're going to have y equal to 2. This graph is going to cut at y equal to 2. And this graph here has no what? Has no x intercepts, because when our y is 0, so when y is 0, we have 20 over, then we have 10 minus 3x, 3x minus x squared. So when we cross multiply this, the x value goes. So meaning this function does not have the x intercepts, but it has a y intercept, and this is just going to cut there at 2 like that, and continue to go closer and closer to the other point. So this is going to be like this, and that point there is going to be 2. So this is how you sketch this rational uh, rational function. All right, and this marks the end of this class.